Okay, so let's go through few of the questions of linear algebra, and that would be not too much based on the previous year question. So, but paper is new, so it would be good to keep these in your bucket, right? And if you are not very much familiar with this concept, then it's good to skip this and stick with your PYQs question, because even if you look at the sample paper, most of the questions are based on the previous year, right? So okay, let's look at this first question. We have given this system of equation ax is equal to b, right? And what we have done, we have performed some row operation, or you can say you have done some elimination, and we have reduced this matrix A is equal to b to ux is equal to c. Alright, and now we have the this equation, that is ux is equal to c, and we have given this matrix u, right? And this is x and this is c. And what we have been asked, that in A, give a basis for null space of A. So we have been asked for the null space of this A, right? And the basis for the row space of A, and the basis for the row space of A. So this question is basically pointing out that what will be the effect on the four fundamental subspaces if you do the row operation. Or you can say, since you are doing the row operation and you are converting your system of equation from ax is equal to b to ux is equal to c, what will be the effect on the four fundamental subspace. In question 1, we have been asked about the null space of A, and we have given this matrix U, right? And we have been also asked about this, the basis of this row space of A, right? So let me just go through it, that what will be the effect on the four fundamental subspace. Let's look at this first of all, the null space. So even after reducing your system of equation from ax is equal to b to ux is equal to c, the null space, that is how we write the null space of matrix A, that will be same as the null space of your matrix U. So there will be no change. You find the null space of this matrix U, that will be the equal to the null space of your matrix A. That is the one thing. So let's do that. Let's find out the basis of this null space. So to find the basis of this null space, we are going to find the basis of this null space of this matrix U. So this is U. To find the basis, what we do, ux is equal to 0, right? Right, now you see here we have one pivot, two pivot, so these two are the pivot columns and these two are the free columns. So we can assign these x2 and x4 any number. So we are finding the basis of the null space. So we can assign the x2, let's assign the x2 0 and x4 as 1, and assign x2 now 1 and x4 as 0, and find the other component, that is x1 and x4. So let's first find this x3. So we have to find the x3 and x1, right? So let's use this one. So that will be 3 times x3 plus 4 times x4. So here x4 is 1. So x3 will be minus 4 by 3 here, right? And using this we can find the x1. So that will be let me so that will be 1, x2 will be 0, and this will be minus 4 and plus 8. So 8 minus 4 is 4, so x1 will be minus 4. Similarly, we can find x3 for this basis set also. So that will be 0 and x, so x4 is 0, so x3 will be 0, and this will be minus 2. So this is the basis of this null space, and the basis of this null space of A and U is same. So we have find the basis of the null space of matrix A. And what's the dimension of this null space of A? Dimension of null space of A is 2, because we have in our basis set we have two vector, right? So the basis of the dimension of this null space is 2, and it will be the same as the dimension of U. And basis for the row space, now we have to find the basis for the row space of A. Again, the row space of A is will not get changed, it will be same as the row space of U, right? So if we know what is the row space of U, then we know the row space of A, right? So these two vectors are the row form the basis of the row space of U. So B part is that the row space of matrix A that will be equal to the row space of matrix U, right? And the basis will be 1 2 3 8 and 0 0 3 4. So these two vectors are the basis of this row space of A, or you can say the row space of U. And the dimension is here again. Dimension of your row space of A is 2, because we have the two set of vector in your basis of the row space. Okay, and so what will be the effect on the column space? Column space is not going to, so column space of A will be different from the column space of U. So this is the key point to take away from here. The effect you will see on the four fundamental subspaces after reducing your system of equations to this. The first point is that the null space is going to be the same as A as U. The row space is going to be the same as A as U, but the column space will be not same, right? And the column space of A would be different from the column space of U, right? So this is the key point to take away from here. Now let's come to this question part B, that what does Ax is equals to B, when does Ax equals to B have solution? If Ux is equals to B have solution, then Ax equals to B will have also the solution, because the null space is going to be the same for the solution of both of them is going to be the same, right? So when you will get the solution of Ux is equals to C, when you see this row that is left hand side is 0, and this should be also 0. So to answer to your part B, you will have solution of Ax is equals to B when B3 minus B2 plus 4B1 is equal to 0. Then you will have the solution of Ax is equals to B. Now we have the second part in this. Give a basis for the column space of A, right? So how we are going to find the column space of A? From the fundamental theorem of the linear algebra, what does it say? That the column space, that is the column space, that will be the orthogonal to your left null space. So left null space, right? If we can find this left null space, we can take the dot product with this left null space, that will be 0, and maybe we can find the basis for your column space. So let me do that. Okay, so I think we can, because in C we have been asked that the null space of A transpose, and null space of A transpose is same as the left null space, right? So part C, basis for the left null space, or the basis for the uh, basis for the null space of A transpose, that is the same, that is showing same. So what does it mean? That you have matrix A, right? When you take the transpose, your row is going to convert into the column, right? Now you are looking for the null space. So let me explain it little bit so that you have idea. So the dimension of this matrix U and A is going to be the same, that is 4 3 row 4 column, right? When you will take the transpose, this is what you will get, 4 by 3 matrix, right? So what we are looking at this A transpose, we are finding the null space of this A transpose. That means what combination will give you a 0 vector, that combination you will have to find for the A transpose, right? So by looking at this, you see that from here you can get the combination, linear combination, that what combination you will find the 0, right? So the basis for our left null space. So I have not explained this part in greater detail. I am assuming that you know all this thing. So basis for your left null space would be, so you can get it from this combination, that is 4 minus 1 and 1. That will be the only set of vector in your basis, and the dimension of this left null space will be 1, because we have only one vector here. Okay, now if we know this left null space, then what we can do is we can take the transpose, or we can take this vector that is in null space, and here let's suppose that we have some column space, a vector in your column space, that should be equal to 0, right? Because these two subspaces are perpendicular, orthogonal. And from here you see that this is a rank 1 matrix, and these are the free columns. So we can set this variable to value, maybe any value, that is 1 0 or 0 1. So that will give you the basis of your null space, sorry, basis of your column space. But we have to find this C1, right? So here C1 will be 4 times C1 into minus 1 times C2, so that will give you 1 by 4. And here we have 4 times C1 plus 0 plus C2, that is equals to 0. So 4 times C1, and C1 is 1, so this will give you minus 1 by 4. If I take the dot product between them, so that will be 1 minus 1, so 0, so minus 1 0 1. So okay, so we have got our basis of this column space, and the dimension would be 2. Dimension of the column space would be 2, right? The overall point in this question, that what will be the effect on your 4 fundamental subspaces when you are applying the row operation, and you are converting your matrix system Ax equals to B to Ux equals to C. The null space is going to be the same, the row space is going to be the same, but the column space of matrix A and U will be different, right? So U will have the different column space, A will have the different column space. And also what we looked for through this question is all the 4 fundamental subspaces, right? So that is about all about this question. We will look more question on